All right. Hello, random person. Whoever may be saying this, it might be a completely different person than whoever was asking the question on the ED discussions. Okay, so let's go through and answer these questions that you have answered or that you have asked. So in terms of like what the program is going to do, the things that you listed are correct. So one, fork the necessary child processes to handle sort based on the command line number. That's correct. Parse a standard input as one word comes in and deal it like parse each child process. Also correct. Once complete, send the end of file to close all sort processes to start sort. Instead of you can't quite send an end of file. You just have to close all of the streams, and that sends a quote end of file. Basically, it just closes the stream, and the sort processes and everything know how to deal with it. And the last thing is once sorted, merge and Uniqify. Correct. All right. So you are lost in how to deal each word to the child processes. Let's start with that one first, and then we can get on to how to get the sorted list back from each child. Okay. So first things first. I'm gonna guess that you already understand how to, well, the general structure of this program. The first portion is going to be the parser, which that's going to be the first thing, and the task of the parser is going to be to get like standard input, and then tokenize, and then this is where this comes into play. So get standard input as a line. Oh, whoops. Yoink. Sorry. And there's actually a step in between tokenize. So you're also going to want to sanitize. So this will remove all of the periods and all the other things. I don't entirely think it'll work with Unicode characters, but you can figure that out as you go along. But yeah, so the first portion is going to be the parser. So sanitize, tokenize, and then this will send data to file buffers. All right. So now I'm gonna guess that one of the questions that you're gonna have is, what do you mean by file buffers? Question mark. Okay, that's a great question, and we'll get to it in a second. Okay, so now you have the parser. The next portion of information that you're gonna have is you are going to have the sorter, and we'll get into the general outline of this in a bit. And the last portion is going to be the silencer. Whoops, let me just do this real quick. Let me just do output. The output silencer. All right. And this is very, very simple. Basically, this is going to be like an interview question, and that interview question is given a sorted list, given a sorted list, print non-duplicates. And this is very simple. And also without making an array. So basically what that means is the space complexity should be constant. You shouldn't create any new data. You shouldn't create any new data to be able to allocate any of the things into these arrays, and you shouldn't have to have like another you shouldn't have to have another array to keep track of the words that you've gotten and another array to do that. Now, that is what you do without a sorted list. So yeah, you don't, one of the constraints is without making an array, print non-duplicates. That's really simple. Basically, you have a list of sorted words, A, B, C, D, and all the letters are all the letters are words. Imagine that. Really simple algorithm. Basically, you go through. You can basically just say, is the next letter the same the same letter as I've encountered? If it is, then proceed up until you encounter a letter that is not the same, and then do the same. So this is really simple. You just have a B. Is there another B in front of you? If not, go and carry on. If there's no B in front of you, you don't need to like go through the entire list because it's already sorted. You can just straight up move your pointer to the next thing, and then you can. And by the way, pointer does not actually mean pointer. I just mean like a processor thing, a point. And then same over here. You have a C. Is there another C in front of you? Okay, cool. There is. Move on to the next D. Okay, D, D. Move on to the next, and do that until you reach the end of the file. All right, cool. You're done. Simple. Very, very, very simple. I wholeheartedly believe in you, and that is very PogChamp. I don't know why I just highlighted all that. All right. Anyways, back to the other stuff. So the juicy stuff happens in the parser, and it happens in the sorter. So basically, the parser does all this, and we'll talk about this in a second. So the sorter, you have a K. I don't like that color. You have a K number of processes, or a K number of tasks. K number of tasks. And with this K number of tasks, this will tell you how many, like, so it tells you how many threads and forks or slash forks you make to the sort function, or yeah, the sort thing for Unix, you know, like the slash bin sort. So basically it tells you how many of these you need to spawn, and that's pretty cool, right? So afterwards, what it once you have all of these, basically you go through and you have these file buffers. You send all of the buffered input, so like the buffered files. So these are gonna have file pipes. Whoops. Yoink. So these are gonna have pipes, and as you have already noticed, or as you've already said, you already know what pipes do, but let's just reiterate. So the pipes are going to have an in and then an out, and that's going to be the same thing for all of these. So you can imagine these input-output file descriptors, or pipes, as a small bucket to be able to contain the words that you have amalgamated so far, or that you've gotten so far. Now, we're very close to answering the question of how do you give like an equal letter or an equal amount of words into each of these, and also at the same time we'll be answering how these come together to make one large assorted list of words. All right, so basically, oh, whoops. So you actually, we're gonna answer one of your questions right now. So one of your questions was how do you get the sorted list back from each child? So, fun fact, you don't. Basically, what all of these do is, let's do this over here. So bin sort. All right, cool. So this is the program bin sort. Cool. Basically, all that you do is you are going to close out the inputs because, well, you're not reading any data, right? And for the sorter, you are going to say, I want to output all of my data into the bin sort. And you can do this very simply. I will post the relevant Stack Overflow in the description, and it is actually this one. So basically, how to pipe to sort and back to main. It's pretty It's pretty simple, and there's even very nice MS Paint things that have been done over here. This is fantastic. And actually, this does exactly what I want to show you. Basically, the parents write into the pipes, and then the pipes will send all that input over there, and you'll keep going through, and then basically one of these children will spawn a sort process, and then that pipe will then take all of that data and then send it to the sort. But that's only for one sort. We have a k number of sorts, so that's actually very important in this scenario. So how do we do that? Well, basically, after you have given all of the data into these quote-unquote file buffers, what you can do is just say, I want to write, oh, and by the way, write is a function that is going to be given in I think it's uni, like Unix std, like uni std. I think it's in this library. Yeah, I'm pretty sure that's in that library along with the read function. Okay. Anyways, so what you're gonna do is you are going to write. You're gonna go through, like you're gonna have a little for loop. I'm gonna go down over here. Actually, I'm gonna go over here. Yeah. So let me show you the algorithm. Okay. Algo. Whoops. Sorry about that. All right, let's do this algorithm together. Sick. Okay. So algorithm, really, really simple. Basically, let's imagine that we have a loop. So for 0 up until the number of child processes, which by the way is going to be given in by the user. So you can do that through the task number. So basically, for 0 up until the task number, we are going to. Oh, and by the way, we have a pipe list. So we have a pipe list that contains the data, or that contains in the first portion of the pipes. By the way, this is pseudocode. This isn't how you will write it actually, or this isn't actually how you write it, but for the sake of posterity, we're going to do that. So this is going to be like the pipe number. So this is going to be like which pipe you are accessing. So like imagine that the user has given you 4 pipes. Basically what this is going to do, like 0, 1, 2, 3. The first one is going to be which pipe it is, and then the second portion of this pipe list is going to be like which pipe mode. So pipe mode. All right. And the pipe mode is going to be it's either going to be the pipe input or the pipe output. And this, by the way, is denoted by the number 0 and the number 1. Disclaimer, I might have messed that up. They might be the opposite way around. Just bear with me. I apologize if that is the case. Okay, anyways, so okay, so, and this pipe mode will denote which pipe you actually deal with. So it's either going to be the input pipe, or it's going to be the output pipe. Bum, 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 bum. Or it's going to be the output pipe. And yeah, that's pretty much how that works. Whenever you call pipe, that returns you a file, like a array of file descriptors. Well, it's going to be 2 file descriptors. It's going to be the input file descriptor and the output file descriptor. And this assumes that you've already opened and closed the correct ones, because remember, if we go back in time, these are going to be closed, and the only ones that we want are going to be the output, because we're not reading input from anything. Okay, now back to the algorithm. Okay. So for 0 up until the task number, we are going to go through our pipe list. Whoops. We're going to go through our pipe list, and we're going to go to the if pipe. So whatever, whatever pipe we are currently at, we're going to go through here. And we are going to basically write, let's see, yeah. So we're going to write the pipe, and we're going to write the data of the output. I can totally spell. All right. And we're going to write the data of the output. And we're going to write that over into like one larger file. So imagine that there is one larger file over here. So yeah, big file. Big boy. And you're going to write that to big boy. Right? So write pipe list output. Let me make this, oops. Let me make this a little smaller for you. Well, for me. Write pipe list output to big file. And this big file can be like created up here, blah, 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 blah. Like, yeah. It can be created up here, and this is basically how it's going to go. So basically you write all of the pipe data to the big file, and then you continue on with your day. You go on to the next one. So we go from here, and now we are going to go on to the next one. So we start at 0. We write all of that data into Big Boy, and then basically once we are done with that. Oh, and by the way, you might want to signify an end of file, like a pseudo end of file, because by the way, these over here do not have end of files, at least from no end of file. At least when you write all the data in, there is no end of file, because these are file streams and they need to be closed in order to be an end of file. So one thing that I highly recommend for you to do is when you are done reading all of your data, you write something like an @ over here to signify that you've reached the end of file. So basically, for blah 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 blah, write the data to the big file until you find an end of file. So until end of file. And this isn't an actual end of file. This is going to be an @ or like whatever you want it to be. Like it can be whatever you want. Just something that you're not going to see in your input. Yeah, so any character that you want. All right. So now once we have encountered that @ or that quote-unquote end of file, we are going to go from 0 and go to the next one. And we're going to do the exact same thing. We're going to go through and we're going to write that data to Big Boy until we've reached that end of file. We're going to go to the next one and then do the same thing. We're going to write that data to Big Boy. And then now we go on to the last one and we're going to write that data to Big Boy. So this is the end of the for loop. So let me just do this real quick, because might as well have, yeah. We're using Python stuff, so indents matter. So yeah, we're gonna go over here. All right, so now we're out of the for loop, and then now you have another for loop from 0 to like your task number, and then now you are going to close all of these all of pipes. Close all pipes. And you're gonna do that through like the pipe list at I, and you're gonna close the output. And you're going to continue doing that and through all of these. And now what that does is there's a very special thing about Unix and piping. So what the operating system does is imagine that there's a large amount of buffer, or a large amount of like words in here, right? So what the operating system does, because doing like read and write operations are very costly, is that until you are done, oh, and by the way, in terms of operating systems, like writing a single letter or writing a single word is about as costly as writing all of these words. Don't worry about that. You'll understand why when we get to operating systems 2. But for now, bear with me. All right. So when you go through these and you write all of this data over here, what the operating system does is it basically creates a temporary buffer. And by the way, you do not have to make this. The operating system will do this. It will take all of this data and it'll store it inside of here until such time that you say, hey, I want to write all of that data. So what the actual thing will look like is going to be something like this. Womp, womp. So that occurs. And then now once you've closed all of these, so now once all of this is closed out, then the operating system goes, okay, the user now has closed all of the streams. Obviously that means that the user wants to take all of this input that I've stored and send it to like this large file. And that's exactly what happens. So now, how does that affect the question that you asked? Well, basically you don't have to get any data from these sorted pieces of data. You don't have to do anything like that. You just have to write all of that information, all of that data into a file. And this temporary thing is a intermediary that the operating system does for you. So don't worry about this. If that is confusing, just imagine this scenario over here. Don't even imagine the whole temp thing. All right. So that is the algorithm for well, this. So let's look at the next question that you have. Okay. So how to deal each word to the child process. So you have said that you do understand, so you understand how to do round robin stuff, but let's just go over it a little more just to make sure that it like all makes sense, because I care about you. All right, let's do round robin. All right, so actually let's start with parser, with the parser, and then we'll get through. So basically you already know how to like do this, like how to do, you may not know how to do this one, but this one's really simple. I'll show you an example in a second. But you do know how to do these, and the reason why I know that is because we have written that in our small shell assignment, and I can show you what that looks like. So basically you have like split lines and you read the input. Don't actually do it this way because these will only work with one line at a time. You have to figure it out on your own, but basically the general consensus or the general thought process is going to be the same. Honestly, the split line is going to be almost the exact same. The split line is going to be the exact same. So yeah, basically you read in that data and then you tokenize it, and sanitizing is going to be a very simple procedure of just going through the string length and checking, is each character that I'm facing a say for rar period exclamation point rar. The algorithm for here is going to be very simple. Given a character, given a string, not words, by the way, a string, we are going to go through and we are going to check each individual character. And if a character is a non-alphabetic character, all we have to do is just replace that, all we have to do is just replace that with a space, right? So all you gotta do is just go in there, and since strings are mutable in C++, or not C++, in C, you can literally just replace it with a space, move on. Is this a character that is, or is this alphabetical? No. So we turn it into a space, we move on. And then so on and so forth. We continue doing this until we have reached the end of the string. And that's it. So that's the algorithm for that. That's very, very simple. Very, very easy to parse. So now back to the whole round robin. Okay, so round robin. All right, so to answer your final question, how to deal each word to the child process. That is a fantastic question. And that is going to be done after you have, actually I can just straight up show you this code, because, yeah, hold up. Yeah, basically this, like while, yeah, sorry, you're not gonna get too much out of me there. All right, so basically while you have, while you are reading input from standard input, or while you are reading a line from standard input, sanitize that line, then tokenize that line into a buffer, and then after you have done that, this is the first portion that you have. So now you are going to have a word list, and this word list is going to be a character pointer or an array of strings. And now you're going to have that word list. So let's go over here. So let's say we have our word list. And by the way, this is the tokenized, these are all the tokenized words inside of the text file. Or I shouldn't, no, this is fine, that's fine. And not inside of the text file. This is like the word list for a line, by the way, because you're parsing line by line. So that's very important to understand. All right, so now this word list is going to be like I love, oh, well, actually it's going to be lowercase because we've sanitized it. I love pandas. Pandas. All right, sick. So that's going to be the word list. So that's literally it. Like, I love pandas. Cool. So here's what we do. Assuming that you have, like, let's say we have a K of 3. And I'll show you what happens when we have a K of 4 as well, because you will not always have even input like this. So I'll show you both of these scenarios in a second. Okay, so given our word list, all we have to do is basically just go and say, all right, let's get our pipe list. Let's make a for loop, for 0, up until, or actually we can make a while. So, oh, that is my dog, I apologize. Okay, sorry. Yeah, basically just make a loop. We're gonna like restart this loop once it hits something, but bear with me. All right, so 4, 0 to like the task number. Basically, we are going to get whatever pipe is currently there, and we are going to write, oh, whoops, like, you can do something like fprintf. Yeah, so you can do like fprintf to write formatted words to this buffer. So you're gonna do like fprintf, whatever like the current word is, like word list at I. So like yeah, so whatever word is currently here, we're just going to send that into our like file buffer. And by the way, or not, oh, I'm so sorry, this is not our pipe list. Don't worry about that. This is our list of file buffers. So this is going to be like file pointer, So file buffers. All right, so file buffers. All right, cool. So basically, this assumes that you have already opened all of the file buffers, etc. All right. Anyways, so for we're gonna go through and iterate through like these file buffers. So with a k of 3, we have 3 file buffers. Cool. So now what we do is we send each word in our word list to whichever file buffer is currently at I. So we do that, and then now our word list at I, yeah. So we're just gonna do that. We're gonna move this a little over here. All right, cool. So basically, I love pandas is you're going to get the word I, and you're going to write it over into the first file buffer. So this file buffer over here is going to get the word I. And now we're going to move on to the next word. And then over here is going to be love. So over here we have womp. Over here we have love. And then now we're on to the next portion of I, which is going to be pandas. So now we have over here pandas. All right. And this is going to be based off of however many words there are in here. So you can basically, like, as long as the next portion, or as long as the current word isn't null, like as long as the current word exists, you can continue going on and looping through here until the rest. Now, what happens if it's a k of 4? Well, that's very simple. We don't need to write any data to over here, so we just kind of skip it because we've reached the end of our word list for our current line, so there's nothing left to write. And then this will continue running every time you read a line from standard input. So like for a word list such as this, yeah. So for a word list such as this, you are going to read the, actually I can just show you the output. Oh, whoops. That's unfortunate. All right. So basically, given this word list, we are going to take each of these words and then transfer them into whichever thing we have. So what I did was I went through, and this will continue going on. So like for the first one, like the line is going to be like A, B, C, D, I love, tafa, if, that, and this, right? So it's 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's 9 words that will go into like 4 buffers. So if we have 4 buffers, there's going to be more data over here. So this is going to be like 1, 2, 3, 4, 5. Oh, whoops. 5. Wait, 1, 2, 3, 4, then 5, 6, 7, 8, and then 9. So this is going to have like 1 more word. But that's okay because like we're going to continue writing this. And also we're not like load balancing, so it doesn't really matter. All right. Anyways, so that is how you get the data into these buffers, and then potatoes. That's how you get the data into these buffers, and that's what the parser does. So that sends data to the file buffers. So now the sorter takes the file buffers, take file buffers, and pipe to sort. So yeah, that's what the sorter does. It takes the file buffers and pipes them to the sort, and then stores the source output of sort. And then now once you get back the output of sort, then you can take that output of sort and send it to your output silencer. So you go and send it to your output silencer, and then there you go. That's the entire thing. Easy money, easy clap. All right. hopefully that answers all of the questions that you have. If it doesn't, you can add me on Discord. Here is my thing over here. So this can be a little bit bigger. Nope. Oof, unfortunate. All right, there. You can just add me on Discord, or you can join the Church of Evan. And I'm on there a lot, and you can ask me a lot of questions. And the invite to that is this. So yeah, there you go. All right, thank you very much, and I hope you enjoyed that a lot. All right, bye.